Welcome everyone to this first demo of computer data in the ocean market. Before we begin, let's look at some concepts. What we mean with computer data. The value proposition is that it's buy and sell private data while preserving privacy. In the implementation, this means there is a data set which is not allowed to leave the premises of the respective data owner, while at the same time an algorithm, a small piece of code, is allowed to run on this data set under certain conditions. While we always had computer data environments running in the wild, in marketplaces I'm not allowed to talk about, there was never the completely public use case of ocean market considered. So the ocean market team set out to create a solution with the guiding principle that the data set is always going to be private. How we decided to do that technically is essentially that we now have a new asset type, essentially algorithms. And before that, we only had data sets. So technically, this means that in our DDO, to the type dataset, we now have a type algorithm. And as you see as an example, a dataset file, for instance, could be a CSV file, and an algorithm could be, in this case, a small Node.js app, which does something. At the same time, algorithms have a bit more rules attached to them. In this case, we decided to allow algorithms to be either public or private. In the implementation, this means that just like datasets, when algorithms are public, they can be downloaded, meaning bought, for the set price. But when they're set to private, they're essentially not accessible. While technically, this means in the background, we set a compute service. We decided in the UI to not expose compute to data onto an algorithm to keep the use cases a bit more simple. When looking at this general data flow, this user flow, this means we are going to have a data set which is published with a service, compute service, and at the same time an algorithm which is published as a type algorithm, and the publisher can then connect those two. And from a general user perspective, they can then combine those, the data set and the algorithm, and run a compute job. What we mean by that is essentially that the data consumer or the person running the compute job will order the data set and the algorithm, so we'll pay the sum of both prices. In that scenario, this also means that just as data sets, algorithms can have both a pool or a fixed price. Essentially exposing small little algorithms to the same automated market maker use cases we have for data sets. Once a compute job starts, it means that there is a Kubernetes environment in which pod is spun up. This also means that this is another centralized component where we already have our provider, where we now have the operator service and the operator engine and the various other smaller microservices. And just as with the provider, this would be up to the respective marketplace owner to properly control that and guarantee no data exposure. Continuing in our general user flow, once a compute job is started and it's running, user can, in the end, access compute results, which are essentially log outputs. So every algorithm has certain access to the underlying pod. So in this case, for instance, there could be an output directory, and in there, the algorithm can write results. And on the market, we simply display them. As for a publisher, it essentially comes down to this process. Every publisher gets a new edit action on every data set with a compute service. And on there, the publisher either allows selected algorithms, which is basically a list of all algorithms published in the market, or simply allows all published algorithms. We also decided for the private by default use case, so every compute data set by default has no permissions attached to it, so there is simply an empty list of algorithms. And now let's look at all those concepts in reality. Let's look at the compute to data changes in the UI. We're currently looking at our staging version where we put everything together for the last 2 months. And as you see, pointed against Ethereum mainnet, there's not much going on regarding compute to data, but you already see some differences on the asset teasers. We now output the type of asset and the type of access on them. We ourselves used a lot Rinkeby to test our compute to data, but for the sake of this demo, we're going to Polygon Matic, which we also suggest to use, especially for compute to data, considering there are a bunch of more transactions involved than for downloading, because essentially 2 assets are going to be ordered. If we look at the UI, you already see some changes here. There is a data set which telling us by this icon that this is a compute asset. And over here we have another type of asset, this algorithm, which by this icon tells us it can be downloaded. When it comes to an algorithm and its presentation, it's not much different than from a data set. Same mechanisms regarding the pricing. In this case, it's a pool. And one difference is that in this case, we output the Docker image, which is going to be used with this algorithm. When it then comes to the respective data set, in this case, this is our new compute UI, and the state of this UI is basically that on this data set, this algorithm we just looked at has been allowed to run. Now let's look at the publisher perspective. So let's say I'm a publisher and I want to have this algorithm also run on my own data set. So as before, I would first come up with my data set. I'm gonna copy that some example data set over so this should work as is, and then let's quickly fill out that and quickly put in our dataset file and its sample file. And as you now see, to the access type, we now also have a compute in addition to download. And just gonna go through with that. And now create the data token, and after that publish the metadata on chain. And at the very end, we're also gonna create some price for it. Okay, this was faster than expected. And I think we're already there. And should get the success message in a second. There we go. Now we have published this as a new asset and allowed compute on it. And as you see, by default, nothing is allowed on it. But for now, let's first also create quickly a pool for it. Let's keep it cheap. Put 50 Ocean in there, a bit higher swap fee, and create a pool for it. So nothing changed here. This is the flow as before, except for this changed computer data interface. Obviously, it makes sense when allowing compute on one's asset to first have a price. That's why I'm going to do this all first. And after creating a pool and moving Ocean into it, almost there. Proving to spend all the things. Now finally throwing everything into the pool. There we go. To be safe, reload the page, and there we have it. We now have a pool. So far, nothing new, but under the asset, there is now a new setting called Edit Compute Settings. And as the publisher, you are then on this new screen allowed to set the allowed algorithms. So as you see, by default, nothing is selected. In this case, we exactly wanted to have this data points algorithm. So we do that and allow it to be run on it. This again is a metadata update transaction. So still have to use MetaMask for that. And after the dataset is updated, this algorithm is now allowed to run on this dataset by everybody. Now let's do the same for an algorithm. Let's say I'm the publisher of this dataset and I want to have my own algorithm on here. Let's say as an example, we're going to publish the same algorithm as this, but with a fixed price. So as before, but this time we go to algorithm and I'm going to copy over all the data you need for that to keep it quick. And in this case, I simply use a secret gist on GitHub for this algorithm. So it's worth quickly looking at that. So this is a typical algorithm. There are a bunch of rules around that, which we're going to document in our docs. But the basic principle is that the algorithm has an input folder and access to an output folder. And during the time of running, it can simply write files only to this folder. And in this case, we're ending up with a output log and a result log, which is essentially the console logs being output. So in this case, I simply used a raw link for that, and this is a secret gist, so it's not so easy to access. This is just as an example, but typically the algorithm would be hosted as a file somewhere. Just for this example, I use this. If we move on, we say, okay, this is a Node.js app, so we're going to use the latest node. It can be also used forever. We're going to allow downloading of it to keep it simple. And this was actually created by us as an example. And we're quickly publishing this. Again, same thing as with datasets is happening. I'm going to create a data token. We'll then encrypt the file URL, put this all into a DDO, which is then ending up on chain. And once we're finished for this algorithm, we are going to create simply a cheap fixed price, so it can be just used easily. And again, we should be actually already done. There we go. Now we have our algorithm. Let's quickly create a fixed price, keep it cheap, one ocean. In the background, creating a fixed rate exchange for that. And now we are almost done in our pricing flow. And now we have it here for one ocean. There we go. Now we're trying to find our recently published data set, where we now can simply go into compute settings and the new one shows up. We allow it. Same thing again, updating the metadata. And after this transaction is done, we should be able to select two algorithms. There we go. There's our fixed price. And now let's look at actually starting a compute job on a data set. Switch to a new account, put some money into it. So let's see. Let's first go to this data set, and we want to run this algorithm on it. All the prices are put together, and because both of them have a timeout, we're buying them for 1 hour. And we're going to buy both assets, which means a lot of transactions in between. And with a fresh account, we're also getting all of them in one flow. Because once you have bought it, you can most likely, in most circumstances, start a compute job again without paying again. This will be then also always reflected down here. based on the timeout on each asset, which is by default set to forever, and it's up to the publisher setting that. Now we already have bought the dataset token. Now we're buying the algorithm data token, and also allowing to spend multiple currencies. And by seeing this, you can probably imagine why we suggest doing this on Polygon. And after we have all those transactions, okay, this was interesting at the same time. The final step then will be to simply sign the compute job, and then it's going to be run. Not yet. Still interacting with the final data set, as it looks like, algorithm. And now we're signing to start the actual job. And there we see, okay, it started. And for now, we can go to our history, and there you see that our compute job is running. As it is right now, we don't have a smart refetch thingy going on here. So for now, it's all about switching the tabs. And in general, everything regarding the output is definitely something we're going to look into further to improve on the usability. But as soon as this is basically finished, you will get a button which, upon clicking, reveals the results. Again, this also needs to be signed, so it's also not just a public link accessible for everybody. So only for the consumer of the compute job. And we already see the results are already published, which as of right now is not a smart decentralized publishing. It's simply put into an S3 bucket for now. And again, this is the whole computer data infrastructure, which is up to the marketplace owner to run and maintain. And this would be then also something the marketplace owner would decide where to store those results. As it is right now, we now see, okay, job finished, ran about in a minute. And now the button becomes active. We sign it, and there we have our log. As you see, you can simply download it. It's also streamed down, and you see we have 114,191 lines. So this is coming directly as the output from the algorithm. And this so far is our first interface for computer data.